Hello, my dear friends. How are you all? Hope your study is going very well. Okay. Now, today we're going to discuss an interesting topic that is called limit of a sequence. You can see in the board I have written limit of a sequence. You might have heard about this term limit. Okay. Suppose two people, something happens between them. One people is saying to another, stay in your limit. But fortunately or unfortunately, I'm not going to discuss about this limit, about that limit. I am going to discuss about limit of a sequence. So sequence, how to represent a sequence? We yesterday we learned about that, and we represent the sequence as an, where my an is a natural number. So for natural number means it may be 1, 2, 3, 4, 5, 6 like this. It may be m plus 1, in between some of m will come. I took just, and for 1 my first term will be a1, a2, a3 like this. M plus 1, m plus 2, an. So our main motto of this class will be whether before before knowing the limit of a sequence, we have to understand what is the convergence or divergence of a sequence. Means whether a sequence is convergent or divergent. I am not going to a bookish definition, rather I will make you understand in a different manner. Achha, have you ever studied or heard about converging and diverging lens? Converging or diverging rays, this is called diverging rays, and this is called converging this. And the concept of convergence or divergence of a sequence is quite similar to this. If the terms of the sequence are converging to a number, if the terms of the sequence, suppose these are the terms of the sequence, if they are converging to a number, let's say a, all the terms I denote as an, then I will say my sequence is convergent. Let's understand by an example. Let's my sequence is like this: 1.00, 1.001, 1.0001, 0.9999, 0.9998. Like this my sequence is going on. All terms are like this. And actually these are converging. That does not mean we have to keep a converging lens here. Okay. So we have to use approximation. This, can I approximate this number as 1? Same for this, same for this, as well this. So I can say my all the terms of the sequence are converging to 1. So this is called convergence. Okay. Let's assume I am giving you a big amount of money. Let's say that money is equal to the equivalent to the speed of light. Okay, that 30 crore I am giving. Suppose while giving I am keeping 100 rupees for my sake. Okay. Will it affect the whole amount of money? This 100? No, no, 100 means, so we can neglect that 100 rupee in front of that 30 crore. Similarly, in a sequence, there are many terms, there are infinite number of terms. If some terms are not converging, then it is also okay. If some terms are not converging to this number, like this, here all terms are converging towards a. Suppose there are some term like 2, 2.01, these terms are not converging to 1. Then also it is okay. We can skip some terms, 10, 50, 100 terms, because then in a sequence infinite terms are there. So let's say when this my n, when my n is greater than equal to m, what is m? Here I remarked here, this is my m. So when my n is greater than equal to m, all the terms of the sequence are converging towards a. Means like this. Let's say for all n greater than equal to n m, my all the terms of the sequence are converging towards a. So what will write? My an is converging towards a for all n greater than equal to m, because I say it is not necessary all the terms should converge to a, because in a sequence infinite terms are there. If we skip some term, if some terms are not converging, then also okay, no worry. Achha, let's see here. See here, here all the terms, I approximate 2 as 1. But all the terms are not 1. All the terms are not 1. They're either, they're neighborhood of 1. Either on the upper side or on the lower side. Either all terms are lying, if I put an interval, means all the terms are lying within this. Yes, all the terms are lying within this. So for defining this interval, let me assume a real number, let's say epsilon, which is greater than 0. Means I am assuming a positive real number epsilon, and I am saying by all the terms like here 1.001, 1.0001, all are lying within this limit. Means the same thing I am telling in different language in the term of interval. Then same thing, that the sequence is converging towards 1. So here also, if I define an interval, my all the terms would lies between a minus epsilon to a plus epsilon. My all the terms would lies between a minus epsilon to a plus epsilon. I can write my a will lies between a minus epsilon to a plus epsilon for every n greater than equal to m. I can write it like this: a minus epsilon is less than a n is less than a plus epsilon. Okay. So yesterday we studied about this. Okay. In absolute function, so I can write mod of a n minus a is less than epsilon for every n greater than equal to m. Understood? So my sequence, when will I say my sequence is convergent? If mod a n minus a is less than epsilon for every n greater than equal to m. And what is my epsilon? Epsilon is any positive number. Understood? And when will I say my sequence is divergent? If many terms are not within this bracket. If many terms are not within this bracket, then I will say my sequence is divergent. Means all the terms, or not all the terms, infinitely many terms are residing beyond this limit. Means they are not staying, my an minus a should be greater than epsilon. Means what does this mean? This means my an is greater than a plus epsilon. Means here they are lying and here they are lying, and my an is less than a minus epsilon. Here I can write my an minus a is greater than epsilon and my an minus a is less than minus epsilon. So if you use mod, then you can get this one. Mod an minus a is less than epsilon is greater than epsilon, then I will say my sequence is divergent. Means there are infinitely many terms will left outside beyond this limit. And this a, and we keep heading as limit of a sequence. This a is called limit of the sequence. Okay, if my sequence is converging towards a, this a is called limit of my sequence. Understood? So let me tell you by some example. Let's consider my sequence is like this. My sequence is, let's suppose my sequence is, let's be 1 minus 1, 1 minus 1, 1 minus 1. Let me write another question also. Let my sequence is like n equal to 1 by n. I have to prove that this converges to 0, and I have to find it whether it is convergent or divergent. Okay. See here, this is my n and this is my a. I have to show this is convergent. This is converging towards 0. What does that mean? We know if it is converging, mod n minus a should be less than epsilon for every n greater than equal to m. And what is epsilon? Epsilon is any number that should be greater than 0. What is my an here? And here my an is 1 by n. 1 by n minus 0 less than epsilon. Or mod of 1 by n is less than epsilon. So if I prove this, then I prove this one. Okay, indirectly. If we solve this, if we get this one, then it is automatically come. It will automatically come. So let's assume any epsilon greater than 0. And epsilon is a real number. If epsilon is a real number, then 1 by epsilon is also a real number, na? Then 1 by epsilon is also a real number. And yesterday we studied about Archimedean property. For every real number, there exists a natural number which is greater than this. Suppose m is any natural number, then my m will be greater than this. And this natural number will be greater than the real number. So I can write here 1 by m is less than epsilon from here to here. If my 1 by m is less than epsilon, we know m plus 1 is greater than m. That means my 1 by m plus 1 is less than 1 by m. So can I write here? It will be less than 1 by m plus 1. In the same fashion, I can write here it will be greater than 1 by m plus 1 will be greater than 1 by m plus 2. Like this. But see, my m is a natural number. So whatever number I will get, that whole number should be positive. Means it should be greater than 0. And I can also write it should be greater than minus epsilon. Because 0 will be always greater than negative number, na? So see here, after all n greater than equal to m, or else I can write like this, my 1 by m is lies between 0 minus epsilon to 0 plus epsilon. Similar manner, my 1 by m plus 1 is lies between 0 minus epsilon to 0 plus epsilon. Like this, all terms after m are lying within 0 minus epsilon to 0 plus epsilon. So I am writing here. So can I write like this? My all n means 1 by n, are lying between 0 minus epsilon to 0 plus epsilon for every n greater than equal to m. See here, 1 by m is m term, m plus 1 term, then m plus 2 term, all are residing within this limit. Then I can write minus epsilon less than 1 by n less than epsilon. By using mod, I can write mod of 1 by n is less than epsilon. Then go this side and you can get this one. You can get this one. It proved, na? It proved. So my sequence is converges to 0. Understood? Let's come to second question. Suppose my sequence is like 1 minus 1, 1 minus 1, like this. I have to find out whether it is convergent or divergent. Let's say my sequence is convergent. Let's say I don't know it is convergent, divergent. Let's say this my sequence is converging towards A. In the previous case, that was given to prove that this sequence is convergent to this one, means my A was given. So here I don't know A. I don't know also epsilon. In that case also I don't know epsilon. So here I am assuming any epsilon. Let's say 0.1, 0.2, whatever you can take, but that should be positive. Let's say 0.2. So if the sequence is convergent, then all the terms. So this is my A. This is my A minus epsilon. This is my A plus epsilon. All the terms should remain within this open interval. Na? All the terms should remain within this open interval. Here I assume epsilon as 0.2. See, all the terms should remain within A minus 0.2, A plus 0.2. Can you find any value of A? Can you find any value of A such that all 1 and minus 1 will stay within this bracket? For example, if we take A as 1, then my limit is from 0.8 to 1.2. So it is containing only 1, but it is excluding minus 1. In the similar fashion, if you take any other value of A, you may get it will contain minus 1, but it will not contain 1. But see, if it is not containing 1, then infinitely many terms. See, there are many terms of the sequencer 1. Then this bracket is excluding infinitely many terms of the sequence. So my sequence is divergent. Or else you can say, if it is excluding minus 1, then it is excluding infinitely many terms. So my sequence is divergent. Also, write one point. This is over. This sequence is divergent. If limit n tends to infinity an or limit of the sequence exists, then my sequence is convergent, otherwise divergent. Otherwise, my sequence is divergent. So I hope all things get clear to you. So thank you for watching. Till then, we'll see in the next video. Till then, goodbye.